Okay guys, this is your chemical bonding video number 2. And in the previous video and on your worksheet that we did in class, we talked about ions that form from single atoms. And for example, we talked about sodium becoming the ion Na+, and we talked about bromine becoming the ion Br-. Now, the thing you have to notice about this is that this is one single atom. And I know that because there's only one capital letter in it. So, that one atom that we see tells us that this is a monatomic ion. Okay? Vocabulary word that you need to know. Ions made out of single atoms are monatomic ions. We've also been talking about binary ionic compounds, which, as we learned in the worksheet, contain only 2 elements. Okay, only 2. So, for example, we've been looking at compounds like NABr. 2 elements, 2 capital letters. Another example would be something like potassium oxide. Once again, only 2 elements, making it binary. There they are. So all of that stuff is what we've been talking about previously. The new stuff that we're going to talk about in this video are polyatomic ions. Okay, poly means more than one or many. So polyatomic ions are ions formed from more than one atom. Okay, and we haven't seen any examples of these yet, so a couple examples that I'm going to give you are the phosphate ion. So it's PO4 and it has a charge of 3-. Another example of a polyatomic ion is this right here, NH4+, which is known as ammonium. So they act just like monatomic ions, and we treat them just like monatomic ions. We just have to write a little bit more, okay? Just a couple of letters instead of one letter. But these are not the only polyatomic ions. In fact, there are several polyatomic ions, and this is just one common polyatomic ion chart. No, you will not have to memorize these. A chart will be given to you. You just have to know when to go to that chart. So kind of take a look at those names, okay? Make sure that you know that those are the names of polyatomic ions and not elements. So now what I want to practice, now that we know about monatomic and polyatomic ions, is writing formulas. So we're going to learn how to write these formulas for compounds made with both monatomic and polyatomic ions, and how to figure these out without having to rely on the diagrams that we were drawing yesterday. So for example, I have aluminum and bromine right here. So without drawing the diagram, what I would do is first figure out what ion they're going to make. And based on its valence electrons, I know aluminum is going to make a 3+ ion, and bromine is going to make a negative ion. So now all you have to do is figure out how to balance those charges, because remember, once the positives cancel out the negatives, you know you're right. So right now I have 3 positives but only 1 negative. So what I'm going to do is start adding negatives until they're balanced. So now, if I total them up, I've got 3+ here and 3- here, so I know I'm right. So put it all together and I get AlBr3, which is also known as aluminum bromide. Our second example here is beryllium and phosphorus, and based on valence electrons again, I can figure out that beryllium is going to make a 2+ ion, and phosphorus is going to make a -3. So now, again, I just have to balance out my charges. This one's a little more difficult, but we can get it. So, I got 3- over here, but only 2+, so I know I'm going to need another one of these. Okay, but I'm still not balanced, so I know I'm going to need another phosphorus. But I've got 6 on one side and 4 on the other, so I'm going to need another beryllium. So now, if I total this up, I've got 6+ on that side and 6- on that side, so I know I'm good. So put it all together. Be3p2, or beryllium phosphide. So now a quick practice using polyatomic ions. First example, calcium and nitrite. I know calcium is just a regular old ion off the periodic table, so I can write Ca2+. But nitrite does not come off the periodic table, which tells me it's a polyatomic ion. So I look at a chart like the one I showed you before, and I know that it is NO2-. So now, just balance your charges just like before. I have 2 positives but 1 negative, so I'm going to need another one of these. There we go. So now we have 2 pluses and 2 minuses. Put them together and we're going to get 1 calcium, so no subscript needed. But we need 2 of the NO2s, so the way that we're going to do that is to put it in parentheses to show that we need more than 1. We close those parentheses like that, and we add the 2 on the outside. And that is calcium nitrite. Our second example, ammonium and oxygen. I showed you ammonium earlier. It's a polyatomic ion. So I look at that chart and I would find that it is NH4+, and oxygen comes off the periodic table. It's a 2-. So once again, just balance my charges like before. Got 2 negatives but 1 positive, so I need another one of these. Balance it out, and I have 2 pluses here, 2- over here, so now I just put them together. But I need more than 1 ammonium, so I'm going to need those parentheses again, NH4, 2, and then just 1 oxygen. So there's the formula for that one, ammonium oxide. The last thing that we need to go over for this video is the naming, which I've been kind of doing it all along, so you may have picked up on this, but I wanted to give you the rules anyway. So in order to name a binary ionic compound, the ones with 2 elements only, first step is you leave the name of the first ion, the metal, alone, completely alone. Second step, you add the suffix IDE to the name of the second ion. So here are our 2 examples of binary compounds that we made earlier, AlBr3 and Be3p2. So if I follow my rules that were just on the screen, I leave the name of the first ion alone, so just leave it as aluminum. And then for the second ion, I just add IDE to the end of the name. So that is bromine, so I'm going to change it to bromide. That's the first one. For the second one, leave the first one alone. It is beryllium. And then change the name of the second ion to add IDE on the end. That's phosphorus, so I change it to phosphide. So those are your names. The other naming rule that you need to know has to do with compounds with polyatomic ions. The only thing you need to know about that is if there's a polyatomic ion there, you use the name of that ion. Otherwise, you follow the rules that I wrote up above. So, for this one, again, I have just a regular old metal, so I'm going to leave its name alone because it's in the front, so it's calcium. But then I see I have a polyatomic ion, so I would refer back to a chart like this, and so I can find that ion on that chart. It is right there. Nitrite is the name, so that's the name that I use when I write it down. So, just add that to my name. That's calcium nitrite. Easy enough. So now, on the bottom, I know I have another polyatomic ion to start, and I leave its name alone. I used it as an example earlier, and it was ammonium. And then my second ion is from the periodic table, so I have to change its name to an ending with IDE, so oxide. So those are your naming rules, and that takes care of video number 2.